Okay, I'm ready to get started. Sorry about the late start there, folks. Okay, let's jump into this. So a couple things before we get started. So you might notice that there is now an exit slip portion on the website. So the exit slip is it's got a few purposes now. So I looked at the feedback. I looked at the feedback that I asked you to submit last week, and one of the common themes, and this was common for almost all of my classes, not just you guys, but a lot of the other classes too. That I think a lot of people want a little more interaction. So I really like that. I really like hearing that my students want to be involved more in the classes. So what we can do to do that is, well, we can do several things. I think what we're going to do is we're going to do some more back and forth. So instead of me just doing a whole bunch of problems, I'd like you to practice some of them too. So what I'm going to try to start doing is, like, I'll do a few examples, like I usually do, and then after that I'd like you to try an example or two. So what that will look like is I'll put an example on the screen, and then I'll give you a few minutes to work on it, and then we'll go over the solution together. And we do that every once in a while anyways. And then another way that I thought we could do this is with an exit slip. So exit slips, they serve many purposes. I've been asked to start doing exit slips because I think either the school division or the province, I forget which, they want to know, like, the proportion of students who are partaking in online learning. So instead of taking like a roll call or something like that, like we would in a regular class, I thought we could do an exit slip because an exit slip kind of like, you can't just sort of click a checkbox. Like, you actually do have to participate, and you do have to watch. You do have to watch the video. Now, the exit slips, I don't want them to be super hard questions, but they are going to require just a little bit of work. So you can't just just check a box or something and say that you're here. You do have to provide a little bit of work. So it'll mean that there's going to be at the bare minimum a small amount of work every class. And the thing that is important to know about exit slips is that I'm not going to be using this as your grade. This isn't going to be part of your grade. So I'm going to be using it kind of just as sort of an indicator of whether or not you can do this work. And if you can do this work, that's great. If you can do this work, then that means that we can kind of move on. If you can't, then we need to sort of backpedal a little bit, and maybe I need to do a little more instruction. So if you can't do it, don't not fill out the exit slip. I need everyone to fill out the exit slip every day, because it'll tell me how many people are partaking in the online learning. I need to report those numbers to the administration of our school. So please fill out the exit slip every time we have a class. It's right at the homepage of our website. So anytime we have class, I'd like you to fill in the exit slip. And the exit slip, you have to fill in a few things, like your name, your email address, and a couple of other things, like your class, the class that you're in. Now, I'm just gonna record that you're present if you submit it. So if you can't answer the question, just say, I don't know how to do this problem, or something like that. Let me know, and that'll help me sort of plan for the next couple of days. Like, if a lot of the students in my class can't answer a particular question, then that means I probably need to do a little more work in that area. So there's that. We have the exit slips. We are finishing up chapter 5 now, so I thought we could have an assignment. So sometime this week I'll be posting an assignment on Google Classroom. This assignment will be worth marks. So I think some students are starting to also feel as though it's time for a new assignment. We'd like to start improving our grades and keep working. So yeah, I've given you lots and lots of homework to practice and practice and practice. Time for another assignment. So this assignment will be on chapter 5 and prior chapters as well. So it will be, like I do try to keep things cumulative as much as I can without being mean. But yeah, so this is going to be sort of a cumulative assignment, so it will draw on some of the previous topics that we've covered. But the majority of the assignment will be about chapter 5, which is, of course, on radicals. I think that was pretty much all the housekeeping I wanted to do. Yeah, so we have exit slips now. That's the main new thing. And I think we've already sort of spoken a little bit about exit slips last week, but now exit slips are in full force. We're using them, and I'm sorry that I had to cancel class last minute yesterday. I thought I had to go to school. Turns out that I wasn't actually needed, but I went anyways, and there was stuff for me to do at school. But my tag class had locker cleanup, so my understanding was that I had to be there. But it turns out I didn't have to be there, but I went anyways. So sorry about that. Thank you for your understanding. Okay, in the meantime, a student over the weekend emailed me about this question. I'd like to solve this question because it is a little bit different than what we're used to. I mean, I shouldn't say that. It's a little bit different than most of the questions that we've done. So we want to rationalize this denominator. So the main thing that makes this question different is this 3. And we've done 1 or 2 problems similar to it, but the way that we rationalize this denominator is a little bit different than if we were to rationalize the denominator with a square root involved. Oh, excuse me. Hey. So we're gonna do this. We're gonna start with this problem, and then what we're gonna do today is we're gonna do a bunch of examples. I'm gonna do a couple examples, and then I'll get you guys to do a couple of examples, and we'll go over the solution together. And then finally, I'll leave you 1 question to work on as an exit slip. So yeah, that's what we're gonna do today. So let's take a look at this, and let's first of all talk about, like, what are we trying to do here? We're trying to rationalize the denominator. Well, this is the denominator right here. So that's the denominator. The denominator. And currently that denominator is inside a cube root. So we need to get rid of, I should say, our goal. Our goal is to get rid of the cube root. Okay, so we're going to get rid of the cube root. That's our goal. So I'm going to write the question out again. So I've got 20 times the cube root of 6t over 5. Okay, so I want to get rid of that cube root on the bottom. So first of all, I'm going to write it as 2 separate cube roots, right? Because a radical of a fraction is the same thing as like a fraction of radicals. So I'm going to say this is equal to 20 times the cube root of 6t over the cube root of 5. Okay, so this is what we're trying to get rid of. So I want to turn this into 5, not the cube root of 5, just 5. Okay, that's what I mean when I want to rationalize the denominator, because the cube root of 5 is an irrational number, right? That's an irrational number. So we want to turn the denominator into something rational. So I'm going to write it out one more time, but this time I'll be multiplying some stuff. So I've got 6t, okay, and I've got the cube root of 5, and I've got to multiply some stuff. Now, you might be tempted to say, okay, well, I got to multiply by the cube root of 5 over the cube root of 5, right? That's what we did with square roots, right? But it's not quite that simple, Okay, by the way, this is wrong. We don't actually do this. Let's review why we did that with squares. We'll come back to that in a second. But, so when we rationalize square roots, when we rationalize square roots, we multiplied, I guess the denominator with the square root. Square root. For example, if I wanted to rationalize 1 over the square root of 2, I would say, okay, here's my 1 over square root of 2. I'm going to multiply it by the square root of 2, the square root of 2, and that's going to give me the square root of 2 over 2, right? Because root 2 times root 2 is equal to the square root of 2 squared, that's a square symbol, and the square root of 2 squared is equal to 2, right? Now, this is a little bit different, so I'll say it's different. It's different with cube roots. And I should say, and higher order radicals like 4th roots, or I'll say 5th roots 2. Okay, it's different. It's different. We can't just multiply by itself again. Okay, so let's think about that for a second. Okay, so let's think about the cube root. Let's do the cube root of 2. If I did the cube root of 2 times the cube root of 2, that's equal to the cube root of 2 squared. Well, let's think about what the cube root of 2 is. So if I cube the cube root of 2, then I get 2 back, right? That's what it means to be a cube root. So this is not equal to 2 anymore. I need the cube root of 2 to the power of 3. Like if I cube the cube root of 2, this is equal to 2. Come on, 2, there we go. But the cube root of 2 squared is not equal to 2. It's not equal to 2. We have to cube the cube root in order to cancel out that radical. So, and that's what's going on here. In this question, when I want to rationalize this denominator, I can't just multiply the numerator and the denominator by the cube root of 5, because this is going to give me 20 times, well, we'll have the cube root of 30t over the cube root of 5 squared. Now this exponent of 2 and this index on the radical of 3, they're not the same, so they don't cancel each other out, right? The only time that I can cancel those out if those two numbers are the same. So we have to ask ourselves, how do we get that cube, like this cube exponent? Like how do we turn this? So how do we get this to be 3, right? Because we want the cube root of 5 cubed. That's what we're going for. If we can find this, then the cube root of 5 cubed is just 5. And that's our goal. That's what we really want to get. So let's think about how we could get the cube root of 5. So if I have the cube root of 5, and I multiply that by the cube root of 5, this right here is the cube root of 5 squared. I don't want that. I want the cube root of 5 cubed, so I would have to multiply it And you know what? I'm actually going to colorize this. This is going to look much better with colors. So if I were to take this and multiply it by the cube root of 5, I'm going to get that this is the cube root of 5 squared, which is not what we want. But if I multiplied it one more time, then this whole thing would be the cube root of 5 cubed, which is equal to 5. This bottom one is not equal to 5. So if I were to start off with this green portion here, if I was to start off with this green portion, right, which we have, right, that's our denominator. Where is it? So here's our original expression. There's our denominator, the cube root of 5. If I were to multiply that by the cube root of 5, and then I multiplied it again by the cube root of 5, I would be done, right? I would be done. So what is this? What is this here? Okay, well, let's take a look. And let's stick with these colors. It's color coding. So the cube root of 5 times the cube root of 5 is equal to the cube root of 5 squared, right? It's the cube root of 5 squared. So that's what we're going to multiply the numerator and the denominator by. So I think that I've kind of run out of room here. So I'm going to copy this question again. Let me just bring it down here. Copy. Okay, and I will bring it back down over here. There we go. Okay, so I'm going to sort of line that up too with, there we go. Okay, so this is what we have to work with. I'm going to multiply the numerator and the denominator. I have to multiply them by the same thing. So I'm going to multiply it by the cube root of 5 squared over the cube root of 5 squared. Okay? And then when I do that, in my denominator, I've got the cube root of 5 times the cube root of 5 squared. So in total, the denominator has, and maybe I'll write this underneath, the denominator is going to look like, well, let me write everything else out first. I've got the cube root of 5 cubed, right? I've got the cube root of 5 cubed, and the numerator has the cube root of 30t, right? Because I've got 5 times 6, which is 30, times t. So let me move this down. This is getting a little crowded. Yeah, that's better. And we don't need these anymore. Okay. And, well, the cube root of 5 cubed is just 5. So this is going to be 20 times, rather, the cube root of 30t all over 5. And we can keep simplifying this. I'm just going to bring this back up. So this is equal to, well, 20 over 5 is just 4, right? 20 divided by 5 is 4. So this is equal to 4 times the cube root of 30t. And let me think. Are there any perfect cubes that are a factor? Are there any perfect cubes that are a factor of 30? I don't think so, but it's worth checking. So 1 is a perfect cube, but that doesn't count because we always have 1 as a factor. And if we factored out 1, it wouldn't change anything. The next perfect cube is 2 cubed, which is 8. 8 is not a factor of 30. The next perfect cube after 8 is 3 cubed, which is 27. 27 is not a factor of 30. And I think it's plain to see that the next perfect cube is going to be larger than 30, right? That would be 4 cubed, which is 64. And 64 is certainly not a factor of 30 because it's too big. So we can't simplify that anymore, and this is our final form. So we are done. Okay? Yes. Oh, yeah. Really good point. Fantastic point. Thank you. Yeah, so Mr. Bennett made a mistake. Imagine that. So this is actually, I think this is actually going to be 150 because I made a fatal error. So I did a fantastic job of dealing with the denominator, right? I gave myself an A+ for that, right? Cube root of 5 times the cube root of 5 squared, right? Taking care of that. I just spent 15 minutes talking about how that works. I forgot about the numerator because I'm not just multiplying by the cube root of 6t times the cube root of 5. I'm multiplying it by the cube root of 5 squared. So, pardon me. Let's backtrack just a little bit, and I'm just going to sort of erase the numerators here, and then we'll deal with the numerators separately. Okay, so I'm hoping that we're okay with how the denominator works, but I forgot we have to deal with the numerator. Okay, so let's just think about what is going on the numerator. So I've got the cube root of 6t times, well, the cube root of 5 squared, that's equal to the cube root of, well, 25, right? Because it doesn't really matter where this exponent is. So just on the side here, so I'll kind of make a little bubble. So I'll like as an aside, if I have the cube root of 5 squared, that's the same thing as the cube root of 5 squared, where the exponent is inside the bracket. Those two things are equal, okay? So this means that I've got 6t times 25, and that is, well, 4 times 25 is 100, so 6 times 125 is 150. So this is going to be the cube root of 150. Now, did someone say something? T, thank you, 150t. Okay, and I still am fairly confident that there are no factors, no perfect cube factors in this, but let's just double check. So again, 1 is a factor, but that doesn't count. The next one is 8. 8 is not a factor of 150. 27, not a factor of 150. 64, not a factor of 150. And the next one is 125, right? 5 cubed, it's 125. 125, although it kind of looks like 150, it's not. Kind of a similar number, similar factors, but it is not a direct factor of 150. And then the one after that, 6 cubed, I forget what that is, 216. 216 is not, it's too big, right? It's too big. So yeah, so this is the final form. So thank you for pointing out my mistake. I totally forgot about this exponent here because I was focusing on the denominator. I was a little sidetracked there. So I hope that answers that problem. And like I said, if you ever have problems in the homework, shoot me an email, shoot me an Instagram message, or Discord. I really like Discord. I think that Discord is a great platform for our class. So yeah, just shoot me a question on here, and I can address it in class. Because it is a little bit hard to sort of like text you a solution or something, but to have a little bit of class time devoted to this is good. So that was the example I wanted to show you. Now it's your turn to try one. I'm going to give you 5 minutes to solve this one. This is going to be part of our practice test for this chapter. So this is going to be okay, how about, so we're going to do this question. So we're going to express as a radical in simplest form. Okay, and if you wanted to, you could look this in you could look this up in the textbook and then look at the solution, but I mean, why, right? It's not worth any marks. So let's actually go through this one. So it is 2 times the square root of 5n times 3 times the square root of 8n, close brackets, and the denominator is 1 minus 12 root 2, and here n is greater than or equal to 0. So that just tells you that we're not going to be taking any square roots of negatives, that we're all checked out. So so that's it. So in simplest form, this means we need to rationalize denominators, make sure there are no square factors inside square roots. And that's pretty much all you need to do. So no square factors inside the square roots, and you need to rationalize the denominator. So you know what, this looks like maybe a slightly more challenging question. So maybe I'll give you 7 minutes. I guess you can't really see that. Maybe I'll do this. Can I? There we go. There we go. And okay, that looks better. So I'll give you, what did I say, 7 minutes? Okay, I'll give you 7 minutes. In 7 minutes, we'll go over the solution together. I want you to I mean, if you don't already have pencil and paper in front of you, now's the time to get it. I know I've said this several times, but I do really hope that when you are when you're watching these videos, that you actually are following along with a pencil and paper and partaking in it, that you're not just watching it. So so yeah, now would be a great time to get a pencil and paper if you don't already have it and work on this problem. You've got 7 minutes, and I will see you in 7 minutes from now. Hello. Yeah, I just turned my webcam on. I just went to go get some water, and no point in just watching my empty living room. Okay, let's solve this one together. Okay, so I'm gonna just go over it very quickly. That's kind of the purpose of this. I'm not gonna be explaining all my steps. I mean, I'll explain them, but I'm gonna go super fast. So keep up. Okay, so 2 times 3 is 6. So I've got 6 times the square root. Well, 5n times 8n is 40n. Okay. And I'm gonna leave the rationalizing of the denominator till later. So I've got 12 root 2. Okay, great. And I think I can factor out a perfect square. I can factor out a 4 from 40, and this should be 40n squared. So this is I can factor out actually a 4n. This is n squared. It's supposed to be working fast here. So I can factor out a 4n squared, which gives me 2n. So that's 6n. Sorry, 12n. 12n times root 10 all over 1 minus 12 root 2. Okay, that's good. And now this, I'm going to rationalize the denominator by multiplying by the conjugate. And the conjugate in this case is 1 plus 12 root 2. So I'm going to multiply by that over 1 plus 12 root 2, right? And let's see what we get. So remember that we're going to have to use the distributive property. So I'm going to have 1 times 1. Actually, let's do the denominator first. Let's do the denominator first. So here's my fraction sign. We've got 1 times 1 is 1. And then I'll have, I mean, if I really want to go through it, I could write 1 times that and then 12 times that, right? But those are going to cancel each other out. That's the whole point of multiplying by the conjugate, okay? So instead, I'm going to multiply just the first one and the last, or sorry, this one and this one. So I'm going to have 12 times root 2 times 12 times root 2, which is 12 times 12, which is 144, times the square root of 4, which is 2, right? So that should be 288. And I believe that is negative because I've got negative times a positive. So that's my denominator. My numerator, I am going to, again, have to use the distributive property. I'm going to have 1 times this whole thing. So we got 12 and root 10 plus this second portion times this whole thing. So that 12 times 12 is 144. We've got 144n, and let's multiply the radicals together. 10 times 2 is 20. So that is my my numerator. Now we can simplify this quite a bit more. I've got 12n root 10, so that I don't think I can do much with that. 12n times root 10 plus 144 n times 20. Well, 20 has a factor of 4 in it, so 20 is equal to 4 times 5. So I can factor out that perfect square of 4, which gives me 288 n root 5 all over 1 minus like this whole thing is 288. So 1 minus 288 is negative 287. So I've got negative 287 as the numerator. I believe that's pretty much simplified. But let me think about it a little bit more. I think that's pretty much all we can do. Let's see here. I'm just thinking of any common factors. I don't see any common factors here. So the only factors that we have in 12 are 2 and 3. Those are the only prime factors of 12. 2 is certainly not a factor of 287, and 3 isn't a factor of 287 either. So as far as I'm concerned, this is simplified. Let me check my answer with the back. So this was, by the way, this was page 306, number 8. Okay, so I'm going to take my solution with the back of the book and let's see what we get. Because as we all know, I'm perfectly capable of making mistakes. So I say page 306, 306, 306. Here we go. And that was question 8. Yeah, that looks like what we got. They put the negatives in a different spot, but it's the same thing. So 12n root 10, 288n root 5, or 287. Yeah, okay. That's that. Okay, so it's time for our exit slip. So this was our kind of our warm-up. And if you, I think, I just checked, I think someone put this solution as the exit slip, which is fine, not a big deal. I mean, I'm still sort of like interpreting that as though you're present. Like the primary purpose of the exit slip is for attendance. But let's do another one. Let's do. How about? Oh wait, I've got a good question for you. Let's do, if I can find it. Where is it? It's somewhere on my computer here. No. Grade 11. Okay. Come on, where are you? Aha. We'll keep it simple. Come on. And you know, I think that it's not super easy writing things like square roots and all of that on a keyboard, but you can just do your best. If you're not sure how to type something in, just ask. Okay, where is that question? So we'll do a radical equation. Yes, here we go. This is the question I was looking for. Okay, so exit slip. I want you to solve the radical equation, square root of 2t minus 3 equals 5. Okay, so that is your exit slip. It has to be completed before midnight tonight. Okay, if I were you, I would do it right now, but I'll still accept it all the way until midnight. And the reason for that is just because the way my computer program works is that it's going to take all of the submissions, look at the timestamp of the submission, and then extract the date from it, and then sum all of my entries with that date, and then that tells me how many people were in class on this day. So if you're not watching the live streams live, that's fine. You can still do it after the fact, but you still need to watch them day of. Okay. So there's our exit slip. Solve it. If you have any questions, don't hesitate to ask. If you want a little bit of help, yeah, that's fine. And if you're totally like, I have no idea how to do this, write that in the exit slip. That's still good information for me. It's not worth marks. That said, sometime this week, probably later on in the week, we'll be having an assignment on all of this material. So that'll give you an opportunity to show me for sure that you know this stuff, and we can improve that grade. Okay, I'm gonna sign out. I'll talk to you guys tomorrow. Yeah, what's up? No, don't take a picture of your solution. So like let's say you have like I don't know, maybe your solution is like x equals 3. Punch that into the form. It's just a text-based form. So there's no, in this case, that there's no option to have a picture. Just punch it in. If for some reason, and in this particular example, I'm pretty sure there's no square roots, but maybe x was equal to the square root of 3. Like typically what we would write is we would say you could write this on a keyboard: x equals and then this is like the universal way of writing square roots on a keyboard is SQRT, and then you would square root of 3, and you could write that with a keyboard, right? So it's been ever since I think the 70s. There's been a lot of development in how to write mathematical equations and stuff using a keyboard, because let's be honest, it's not simple, right? All of these symbols are things that are really easy to do with a pencil and paper, not super easy to do with a keyboard. So if you have any square roots, you write SQRT, that means square root, and I can post a link on the website on how to punch in mathematical symbols and stuff. Does that answer your question? Okay, another question, go ahead. Yes, exactly. Type in the answer that you got on the Google form on my website. So if you go to the just the homepage, it's not buried anywhere. It's right on the very homepage. It says exit slip right on the homepage. Just click that link and then punch in your solution into there. And if you get it wrong, don't worry. That's all right. That's just information for me saying, okay, maybe I need to do a little more work in this area. We need to maybe revisit some topics, okay? Just the answer. Don't worry about your work. I just want to see the answer. Yeah. I would much prefer your school division email address. However, if you use a different email address, the form will still work, but I would prefer you to use your school division email. Yeah. Any other questions? No? Okay, great. Well, I'll talk to you guys tomorrow. And like I said, if you have any questions, don't hesitate to ask. And in the meantime, be well and hope you have a good rest of your day. Okay, bye-bye, guys. Bye-bye.